A tower crane can lift 20 metric tons of steel 1,000 feet into the air with pinpoint precision. They are the silent, indispensable workhorses of our modern skylines. But suspended over our heads, they operate on a knife's edge, where a single miscalculation or a single moment of human error can lead to absolute catastrophe. We trust them with our lives every day, but how safe are they really? The answer lies not just in their immense steel structures, but in a sophisticated network of hidden systems. And sometimes, as was the case in a tragic 2019 crane collapse in Seattle, the most catastrophic failures have nothing to do with the machine itself. When we look at a tower crane, our eyes are drawn upward to the soaring mast and the sweeping jib. But the crane's safety begins long before it ever casts a shadow on the job site. It starts with months of rigorous site-specific engineering. Before a single component is delivered, engineers conduct detailed ground pressure studies and wind load analyses, creating a virtual model of how the crane will behave in that exact location throughout the year. The crane itself is a marvel of over-engineering. Each 10 or 20-foot mass section is fabricated from high-tensile structural steel, a material with a tensile strength often exceeding 70,000 pounds per square inch. To put that in perspective, a solid 1-inch square bar of this steel could support the weight of 4 full-size pickup trucks before it would reach its ultimate breaking point. Though in practice, safety margins ensure far lower loads are used. The welds that join these components undergo stringent inspections, often using magnetic particle or ultrasonic testing to detect any invisible flaws. This incredible strength is then shaped into a lattice structure. This isn't just for weight savings. It's a carefully calculated design of interconnected triangles that is incredibly effective at handling the complex forces a crane endures. It's built to resist the immense compressive load from its own weight and the cargo, the tensional, pulling forces on the jib, and the torsional twisting from wind and the crane's rotation, channeling it all safely down the mast. All while presenting the narrowest possible profile to the wind. Furthermore, every single lift is meticulously planned. A certified lift director will create a detailed plan that outlines the weight of the object, the required radius, the path of the load, and potential hazards. This isn't just a suggestion, it's a mandatory blueprint for the operator to follow. This intense upfront investment in planning and structural integrity is the invisible fortress that underpins every single action the crane takes. It's the first and perhaps most important layer of safety that ensures the machine is fundamentally sound and prepared for its environment. A modern tower crane is governed by a multi-layered network of redundant safety systems, a guardian network that acts as its brain, nerves, and reflexes. At the heart of it all is the Rated Capacity Indicator, or RCI, often called a load moment indicator. This is the crane's digital brain. Using sensors that measure the load on the hook and the angle of the jib, it continuously calculates the load moment, the force of leverage, and compares it to the manufacturer's load chart. The operator sees a clear display showing the actual load versus the maximum permitted load at that radius. If the crane approaches 90% of its limit, a warning light and alarm will activate. If it reaches 100%, the RCI performs a function lockout, preventing the operator from hoisting up or moving the trolley further out. It makes an overload situation virtually impossible. This digital brain is backed up by a web of physical limit switches, the crane's nerve endings. An overhoist limit switch is a critical safety device that prevents the hook block from being pulled up into the trolley and jib, an event called two-blocking, which can snap the hoist line. Trolley limit switches at both ends of the jib prevent it from running off the rails. The crane's immense rotating power is also controlled. A slew limit switch prevents the crane from rotating too many times in one direction, which would twist and sever the power cables. Advanced cranes also feature slew speed limiters. As the trolley moves further out on the jib, the system automatically reduces the maximum rotation speed to prevent dangerous momentum from building up with a heavy load at a long radius. Then there are the brakes. Tower cranes use multiple fail-safe braking systems. The hoist motor is fitted with a powerful electromagnetic disc brake. It is spring-applied and power-released, meaning if the crane loses power for any reason, the brake automatically and instantly engages, locking the load in place. A similar system is used on the slew drive. For descending heavy loads, some advanced cranes also employ a secondary system called an eddy current brake. This uses powerful magnets to create a drag force, allowing for a perfectly smooth and controlled descent without ever touching the mechanical brakes, saving them from wear and tear. Beyond mechanical forces, a crane must also contend with the power of nature. A 1,000-foot steel tower is a natural target for lightning, and so it is designed to be a giant lightning rod. The entire structure is heavily grounded with thick copper cables that run from the highest point down the mast and deep into the earth. When a strike occurs, the massive electrical charge is given a safe and direct path to the ground, protecting the sensitive electronics. The operator remains safe inside the cab, which acts as a Faraday cage, shielding them from the electrical field. On a busy site with multiple cranes, anti-collision systems are essential. Using radio transceivers or sensors, each crane knows the exact position of the others. Operators define no-fly zones in the system's software, and if one crane's jib is about to enter the working envelope of another, the system will provide a warning and ultimately lock out the controls to prevent a collision. Finally, every action is recorded. Modern cranes are equipped with a black box or data logger that records all operator inputs, loads lifted, wind speeds, alarms, and lockouts. In the event of an incident, investigators have a second-by-second record of exactly what happened. This incredible Guardian network makes the machine itself exceptionally safe. But with such an array of automated safeguards, is it possible we've become too reliant on the machine to protect us from ourselves? On April 17, 2019, it was a windy Saturday in Seattle's fast-growing South Lake Union neighborhood. A crew was in the process of dismantling a tower crane at a new Google campus building. The process, essentially the reverse of its assembly, should have been routine. But it turned deadly. Just before 3:30 p.m., as winds gusted over 45 miles per hour, the top of the crane snapped off its pedestal and plummeted to the ground. It crashed onto Mercer Street, one of the city's busiest roads, crushing 6 cars below. 4 people were killed instantly. 2 experienced iron workers on the crane and 2 people in their cars, a university freshman and a former city employee. 4 others were injured. The investigation that followed uncovered a devastatingly simple cause. The failure had nothing to do with the wind, the crane's design, or a mechanical malfunction. The catastrophe was caused by human error. The crew dismantling the crane had removed nearly all of the massive steel pins and keepers that connected the crane's rotating section to its mast sections. According to the manufacturer's procedures, these should have only been removed one at a time just before that specific section was to be lifted away. Investigators believe the crew, possibly in a hurry to finish the job, pulled the pins prematurely. With nothing properly securing it to the tower, the entire 300-ton superstructure was essentially just resting on top of the mast, held by gravity. When a strong gust of wind hit, it was lifted up and thrown to the street below. A multi-million-dollar machine, equipped with layers of sophisticated safety systems, was defeated by a handful of steel pins being pulled out of order. The fallout was immense. The companies involved faced over $100,000 in fines from the Washington State Department of Labor and Industries. More importantly, the tragedy served as a brutal wake-up call for the entire industry. It led to sweeping changes in state regulations, mandating more stringent oversight of disassembly procedures and requiring checklists to ensure every step is followed to the letter. This one event sent shockwaves globally, forcing companies everywhere to re-examine not just their machines, but the culture of safety among the crews who work on them. When schedules are tight and the pressure is high, how do we ensure that established procedures are never seen as optional? The Seattle collapse is a stark reminder of a fundamental truth in construction. The most important safety system on any piece of equipment is the human being operating it, and the team working around it. Crane operators undergo thousands of hours of training and rigorous certification processes to earn their seat in the cab. But they don't work alone. They rely on a qualified rigger to properly attach the load and a signal person who is their eyes and ears on the ground. This team communicates through a precise set of hand signals or radio commands. This human network, built on training, communication, and a disciplined adherence to procedure, is the final layer of protection. When it functions correctly, it ensures the crane's immense power is always under control. When it breaks down, the consequences can be tragic. So, how safe are tower cranes? They are monuments to safety engineering, packed with systems designed to protect against mechanical failure. But as the tragedy in Seattle showed us, their ultimate integrity rests in the hands of the people who build, operate, and dismantle them. Thanks for watching Hard Hat Industries, your source for serious machines doing real work. If you like this, hit like, subscribe, and turn on notifications so you don't miss what's next. Until then, keep your head down and your gear running.